This is video tutorial number 33 for the 3D Experience CATIA generative shape design application. This particular video is going to go into the playlist that is associated with the Surface tab for GSD in 3D Experience. The particular icon under consideration is still sweep, and the profile type is circle. The previous few videos dealt with the type which was line, but now we're going to move on to the type that is profile type that's circle. Therefore, you don't have to create that the profile; it's automatically assumed to be circle. Now, uh, we're going to look at three possibilities within this profile type of circle, as you see below. When you click on the sweep icon, you get this dialog box. And notice that here we have the circle circled out right here. This was explicit, this was line that we have already done videos for both of these. Now we're going to go to circle, and the particular subtype that we're going to look at is three guides. There will be three subtypes that we will discuss in this video, and this is one of them. So notice that the subtypes within this circle is three guides, two guides and radius, center and two angles. And these three are going to be discussed in the present video. Okay? Now, the CATIA V5 version of this tutorial can be found in this YouTube site. And the first one that I'm going to discuss is the three guides. And let me quickly tell you what the story is. You have three curves in space, three guides. So you want to create a circle that's made, you want to make a surface that's made a whole bunch of circles that essentially goes through three guides. And the way this thing works is that the first guide curve that you select is going to be used as your spine, as the spine. And what that means is that at every point of this spine, or this guide curve 1, a plane is generated normal to it. This is the normal plane to the spine because this is selected as default. The first one is selected as default for spine. And then the intersection of this normal plane with the other two guides is found, okay? These 2 points. And a circle is passed through these three, a circle in space is passed through these 3 points. And as the point on the first guide curve or the spine moves, you get all these circles, and all these circles are attached together, and you get a surface. We're going to come back to the other two cases later on. All right, so let's go ahead and do an example. Keep in mind that dimensions are not important here. We are just trying to explain how the process works. So let me create actually two other planes. So I go to wireframe. Here is plane 1, offset from this. Yeah, okay, so let me make it a little bit longer. Fine. This is one of them. We do another one. I can't remember what was the length here. 56. Okay, good. And then I do another one. So for example, another plane offset from this in the other direction, 56. That's good. So I'm going to draw three curves in space. One on the this plane, which happens to be the exit plane, and then two on these offsets. So let's do this one. Let me do this back one first. I'll use the splines for two of them and another line for another one. It doesn't have to be, it can be three splines. It really doesn't matter. So this is one of them. And then another one. I'll do a line here. Fix it. And then on this one, just to show you that they don't have to be parallel to each other. So I created this plane, but I'm not going to use it. I will draw it on that horizontal plane, spline. This is just to remind you that, you don't have these particular curves. Cancel that. These particular curves that we generate, they don't have to be necessarily in parallel planes. There's just three curves in space. Okay, excellent. So, actually, I didn't use this plane. Let me hide this. All right. So let me go ahead to the surface tab. Here's the sweep. We want the circle, profile type circle, three guides. Remember, there's 6 cases here. We're looking at three guides. The first guide curve is going to be automatically your spine. So I select, for example, this. Notice that it's already picked as your spine. Now remember, your spine can be changed later on. You don't have to accept this, but I will do that. A second guide curve, maybe here. Third guide curve here. And let's do a quick preview. And there we go. So what happened is, based on this graph that I mentioned, let me see for a second. Based on this thing that I showed you, a normal plane to the spine has been created. The intersection with the other two curves have been found, and then 3 points in space. It passes a circle through it. Now, it may not be a full circle, but it's a circle. So notice that this is what happened. Okay, so that's the way it works. Now, incidentally, here. We can change the spine. Let's go and change the spine, for example. Let's go, instead of let me say fine. This is okay. I'm going to hide this, and I'm going to go to another sweep. This time I'm going to select the middle one as the first curve, which is going to be your spine, and then this one, and then that one, and then preview. You're going to get a different kind. So depending on how, wow, this. Now, the reason that this is happening is that these three are probably so close to each other. It's the reason that in the end looks like that, is that if you go to the let me say let me hide this, and the reason that you get that gigantic thing at the end is that these 3 points are almost on the same line. That's why the curve that goes through it is going to have a gigantic, or the circle that goes through it is going to have a gigantic radius. Okay. So obviously, if you go to one of these sketches and change it, for example, let me go ahead and make this thing spline. Okay. And I'm going to turn this thing either to a construction or just delete it, either one. So now it says I can't do it with this. See this? It says I can't do it. Okay. So let me go and do another one. Let me go and change this thing. So maybe change this thing, and hopefully exit. Okay, fine. Let me go back here. Well, let me change some of these points. So for example, this one, make it like that. And let's see what happens. Probably this is just as bad. So we go sweep. Between this one, I took the middle one, and then that one, and then that one, and then preview. Yeah. So just keep in mind that in generative shape design, you can pretty much do whatever you want, unless the algorithm fails. And of course, it's not going to do it. It's going to give you an error message. But exactly what you have done is knowing the process behind this. Okay. So that takes care of our first situation, namely 3 guide curves. Now I'm going to do 2 guide curves and radius. I'll explain what it is, and then we're going to do that. Okay, for the second subtype, I use two guides and radius. So let's first of all make sure we understand how this thing goes. I need to have two guide curves, guide curve 1, guide curve 2. By default, guide curve 1 is selected as a spine. And once the spine is selected, a point on the spine is created, considered actually. The normal to the spine is considered like that. This normal plane intersects the other guide curve at the location right here. And what happens is that obviously these two planes, when looked at in that normal plane, once you define a radius, you can draw a circle in that plane passing through these 2 points with a given radius. Now, obviously, the radius must be big enough so that actually you can make the radius. Otherwise, you're going to get an error message. But we'll do an example. Two guide curves and a radius. Okay, we'll do that later on. So let me go to my 3D experience interface. I need two guide curves, so one of them I'll do it in that vertical plane. So maybe something like that. I'll do a spline. Okay, exit. And the second guide curve, I will do it in, for example, this horizontal plane. Maybe something like that. Okay, exit. So basically, I have two guide curves. One of them is here, which is in that vertical plane, XZ plane. The other one is in the XY plane. Okay, very good. So let's go ahead to sweep, circle. Second case is two guide curves and radius. All right. So I have no idea what the distance between these two are, because that will affect what the acceptable radius will be. Okay. But right now I'm going to select my guide curve 1. This is going to be my spine. Guide curve 2 is right here. Right now, the default radius is 20 millimeter. Let's see if it actually can make it. No, obviously that's too small. So let's make this thing 50. Let's see what happens now. Preview. Still no good. Let's make it 100. Preview. There we are. So what it did, it actually created two answers. Notice that there's 6 answers. Let me make this thing a little bit smaller. So maybe let's make it 80. 80, see whether it still gives it to me. Yeah, good. Now, it gives me 6 answers. If I close this, right now it's case 1. If I close it, I'll get the first answer. Double click on it. You can go to the next one, preview. It changed it, but not by much. Let's go to the next one, preview. Okay. Next one, preview. You see each one of these, let me go back here. It looked like you're getting the same thing, but you're not. So if you go to, for example, answer previous one, number 3, let's say preview, and then say OK, you're going to get a different surface. Okay. So what this thing is, it passes through these two curves. This was my guide curve 1. This is my guide curve 2. That guide curve 1 happened to be the spine, by the way. So at every point, it drew a perpendicular plane to the spine, found the intersection of that perpendicular plane with that other second guide curve. So there are 2 points in that plane. You can, once you specify the circle radius, you can draw a circle passing through those 2 points with the given radius. If the radius is too small, you won't be able to do it, okay? And then creates a circle, and then does this circle for every single point on the spine, and then connect them with a surface. So let's go back here. Let's try something else. Let me go back to the first one, actually. Preview, and then okay, see what we get. Yeah. So you can see that there can be dramatic changes. You can always make things. There is no right or wrong. It's just that what is it that you want to do? Okay. And incidentally, let me go back here. Notice that here, I assume that the radius is constant, 80 millimeter. But you can also put a law. For example, let's say it starts at linear, for example, starts at, let me make it 80 and goes to maybe, let's try 150, see how it looks like. Preview. Okay. Okay. So notice that it started at some value, some radius, and it goes to a larger radius. So let me see which one is which, though. It looks like it starts here. Let's try different law here. Let me start at let me start at 150 and go to 80. So see, you go the other way around. Okay, so start at 50, it went 180. Yeah, so you can use a law, and that's pretty much it. So the last one that we're going to look at is this case of two guide curve. The last case is going to be center and two angles, and we'll talk about it in a minute. So this is the third subtype that I'm considering, and it's under the center and two angles. Here's the way it goes. We have two curves here. There is something called a center curve, and then there is a reference curve. Okay, so I have two guide curves. These two guide curves, center curve, reference curve. So a point on the center curve, which is automatically the default, whatever you pick as center curve automatically is going to be your default. The point is selected there, and normal to the spine, which is the center curve, is created. This plane normal to the spine is going to intersect this uh, uh, reference curve at a point, okay, like that. So in that plane, normal plane, we have this point, center of a circle, this point that's created, this is all in that plane, and a circle is drawn like that. Now, the angles tell you how much of this line, by how much this line should be rotated. Angle 1, and again rotated by angle 2. The surface that you're going to get is actually the circle, or the surface of that circle. Let me put it this way. It's this piece between angle 1 and angle 2 that is moved along, creating a surface as the point here is moving along the spine. So it's this piece which is turned into a surface. Okay? All right, let's go and do an example. It's kind of hard to explain it based on this figure, but let's go and do an example. So on that vertical plane, I will sketch spline. So perhaps something like this. This is going to be my center curve. Okay. Exit. And for my reference curve, I'm going to make that horizontal plane. Let me do another one. Exit. So I have two curves here. This is going to be the center curve. This is going to be my reference curve. So now we're going to go to the surface tab, sweep, circle, the third case. For the center curve, we said we're going to take this. For reference curve, we said we're going to take this. some default angles are put in here. That's okay, I have no problem. And notice that the first one, center curve, is always taken as your spine. Well, let's see what happened. Okay, so what happened is that you see 0 degrees, 45 degrees. If I make this, instead of 0, if I make it, for example, 15, so it goes 15 to 45. So basically, this line, 15 degrees, 45 degrees, that surface is generated and displayed for you. Now, a couple of things you can do. For example, if you say, what if I go from 0 to 360? Basically, you get a, yeah, get a surface like that, okay? If you go, instead of the 360, you go to 180, you get half of that. You see that? And you can also change according to laws. Let's try one of these angles. Let's say angle 2. We go from, let's say linear. Let's go from 180 to 0. Not 0, maybe 90. See how it's going to look like. It doesn't mean anything that you put in there is going to work, but let's see. This one worked. Okay. There is no right and wrong. I mean, this is why generative shape design is kind of more complicated than part design, because there's so many things that you can do. And not only that, there is no right or wrong. I mean, basically, you have to look at it as a surface designer, see whether it looks good. And when you pass it on to a analyst and they do all kinds of analysis on it, maybe I don't know, stress analysis or CFD on it, it performs the way it's supposed to. And of course, customer is sitting at the other end, which has to agree with what the surface designer thinks looks good. So we have done the first 3 cases, and we're going to do the next 3 cases in a